I'm going to talk a little bit about who we are, what we do, why and how we varnish. I think going on the presentations that I've already seen so far this afternoon, it's the stuff that's been coming up. In terms of Holiday Extras, we're relatively small in terms of size and number of hits and stuff like that, but I think we still do some interesting stuff. So a brief intro to who Holiday Extras are. We're mainly an airport car parking company, so if you're going to go leave your car at the airport, you're better off pre-booking, and we basically do that pre-booking stuff rather than just turning up, because it's going to cost you quite a bit more. But we're actually a group of other companies as well, so we work closely with Show and Stay, Play and Stay, and they're kind of theatre breaks and thought parks and stuff like that. And we also do a lot of fulfillment for companies like EasyJet, Saga. We'll have pages on their own domains, and they're actually coming through to us. So what do? We were formed in 1982. Turnover last year was about 200 million, about 4 million bookings a year. We have approximately 240 servers across the UK and Europe, so we're also international. We're in Germany. We've got a head office in Germany as well as Italy and a few other places. We have a call centre. We take about 1 million phone calls into that a year as well, and a normal 24/7, 365 days a year on-call rota, of course. And in 2000, last year rather, we moved to the cloud. So a lot of our infrastructure runs from AWS, which is Amazon Web Services. Holiday Extras being a technology-led company, we believe in our hassle-free vision, which is to ensure we give the best customer experience possible. And to do that, we look at the various technologies out there, try different things, and go with what works. And luckily, Varnish is one of those, so it definitely stays in place. So a couple of Webby numbers for you, really. We do approximately 2 million requests a day for just one of our Holiday Extras homepages. But that's static content as well, because we are mainly in the UK and Germany, so there, again, is not really much of a requirement for a CDN. About 190,000 unique sessions a day at peak. And approximately that turns into 47.3 million sessions to a website each year, and about 1.5 billion availability searches, which is why we've got quite a few servers in our infrastructure. So why we Varnish? Well, as I said, we moved to the AWS cloud, and we actually fronted AWS with Varnish servers, certainly for our home pages. Why didn't we choose anything other than Varnish? Well, we had a look at Nginx and Apache Cache and Squid and various other technologies out there, but they seemed not to be highly configurable. We just got to look at the VCL layer and the logic you can get within Varnish, and it's really, really cool. So that's why you chose Varnish. Obviously, it's full page cache. I kind of thoroughly believe in caching as close to the user as possible, and with that, I think you're going to get a lot of the speed gain, and you can get further speed gains if you go lower down the stack, saving you sort of less resources. But caching as close to the user as possible is kind of where it's at, certainly for us. Honestly, that's improved our website speed, which in turn, for a business like us, SEO rankings are important. And just using Varnish, we saw like a month later that our SEO rankings improved quite considerably, so that was a really great move for us. Already kind of spoken a bit about the VCL, how flexible it is. We actually have some kind of website logic in our VCL rather than letting the application do it for us, and that seems to work really well as well. Like I said, geolocation, so we have Varnish servers in the UK and Germany, and that's partly for latency reasons. So with AWS, of course, they're all the way in Ireland for us, or the EU, or even the US in some cases. So fronting that with Varnish means we can still keep decent speed to our customers within the UK and Germany. And of course, saving costs. So when you're in the cloud, you're paying for every little resource you use, bandwidth-wise, server farms, whatever. Therefore, if you're not sending quite so many requests to your back-end systems, you're going to be saving quite a bit of money there as well. And we actually found it helped uptime. We did have a couple of outages, and because we were using Varnish, it kind of saved us a little bit. So our home pages stayed up even though our backends obviously all went down, which was really good as long as obviously the object was in the cache at the time. So that was pretty cool to have that. We partly use it for monitoring in a kind of roundabout way. We have other monitoring tools, but with the kind of back-end probes that Varnish has, we can detect whether the backends are going up or down, and we use those. And we obviously need to look into any sort of problem when that does occur. We are still on version 2.15, but we are on our way to version 3. I've already set it up in test, so we will be there shortly. How Varnish helps? Well, we took our number of web servers down from 8 to 2, which is quite considerable, really. I mean, obviously, like I said, we're a much smaller scale than you guys, but that's still a good saving to show that just how much Varnish can help you save on the number of resources that you require. 2 Varnish servers and 2 web servers, but really that's only for resilience, to be quite fair. Without Varnish, the response time varies. So time to first byte, we find, varies considerably between 800 milliseconds and 1200 milliseconds, but once we put Varnish in front of our website, it's much more of a flat line, not quite so spiky, at around 200 milliseconds. So that's a huge improvement. Just browsing the website as a customer, it's a massive difference to what we had before. We do cache for as long as possible, mostly 6 to 24 hours. Our pages aren't hugely dynamic, which is what's enabling us to do this. And we find that that's a pretty useful kind of ability for us to have. And again, it just helps with the kind of cost-saving scheme that we have because we are a fairly low budget. In some cases, funnily enough, we used to, or kind of still do in some cases, have pages that took over 10 seconds to load, which is a bit crazy. But with Varnish, it still takes just like milliseconds in the end as soon as it's cached by a user. So it's helped us out in that end. And we do fix those pages as and when we find them. So how do we make the move to Varnish? Well, we've only been on Varnish for just over a year. But we did it at the same time that we moved to AWS. And we just literally went around in a loop. So set up load balance servers for the Varnish high availability, and then did a cycle around on configuring Varnish, running tests against live backends, letting loose our QA guys. And that was cycled around a few times just as we kept fine-tuning. And then we eventually did a switch over in the middle of the day. Kind of went in with the middle of the day rather than in the middle of the night. We have a lot of external parties using our site, not just customers, direct people, but travel agencies as well, and various other kind of companies and stuff. So switching over in the middle of the day, they're always quick to phone us if there's a problem, but they didn't really notice anything. So we kept a close eye on impact. And then we have site HX or Holiday Extra site assurance monitors. This is stuff that we set up ourselves. So that's a combination of Selenium, web page test, and Pingdom. And what we do is we allow some of those requests sent from this site assurance infrastructure to hit Varnish or hit the Varnish cache. Some of those requests are not allowed to hit the Varnish cache. And the reason we do that is partly because of the long cache times that we have. We're deploying several times a day to our websites. And if we weren't checking what is beyond Varnish, if we were just checking what's in the cache, then we would have instances where pages may go live broken, but at a time that no developers are in, so that we make sure we're checking what's not live as well as what is live. We put Varnish in front of legacy applications, so the application was about 7 years old, I think, by the time we put Varnish in front of it. And with that, we did have to make some code changes in order to get Varnish to run with that application. It also meant we did have a quite astronomical number of cookies on our site before we moved to Varnish. And now, fortunately, we only really got one real one that we need. We monitor just about everything we can, so with Zabbix as well. Varnish ADM is our friend. We basically, with Zabbix, just execute a Varnish ADM command, which pulls out all of the stats at that specific moment, and then we put them into graphs and stuff, and the graphs are kind of swinging around the walls all the time. And with that, we can check our cache hit ratios, make sure that they're always pretty sweet. So above 90% is what we want to be. Generally, it's higher, sort of 95 region. Because we're caching so long as well, that's why we get a decent cache hit ratio. But our URLs are formatted in a fairly specific way, so we can kind of see how and what we're going to be caching. And not too many worker threads. So to begin with, we did have a slight problem, I think, with the default on worker threads because we kept churning them quite a lot. So it's just, we just eventually found that it's a simple problem of just changing the number of worker threads that we had set up in a config. Like I said, we alert on quite a few things as well, and again, looking at the Varnish backend numbers, we'll alert on those, and again, it would be something that we see on the wallboard. So if we start getting failures at the backend, it's something we will look into immediately. But we alert on loss of connectivity, the port or the process disappearing, kind of things like that, backend going unhealthy, nuked objects. But all of these happen really rarely for us. How we varnish. So this is just going to be a few slides really showing just some of our actual VCL. We do some pretty simple stuff with IP-based virtual hosting. So we've got more than just 2 Varnish servers. Some of them are direct on the internet and not behind load balancers, and some of them are behind load balancers. In this particular case, this is a Varnish server that isn't behind a load balancer, but it had several IP addresses attached to it. But we had several applications as well, fronting or sitting behind this one Varnish server in particular, and load balancing work based on the IP address that the request came into the Varnish server in. We use X44, even though it's not 100% reliable. It's just pretty simple code. I'm sure all of you have seen it before. We also found that we did get a lot of private IP addresses into the application, which is a bit strange, so misconfigured routers, I guess. And we strip those out in the application side where we store the logs. And also, just a bit of Apache code to say that we store the X44 in our access logs as well in Apache. Cookies, yes please. That's partly because it was such an old application that even though we tried, we got rid of pretty much all of the cookies that we had except for one. And because we have a lot of travel agents and the way our site works, we have like this specific ID that we give out to agents. So we know all of our agents individually by this ID, and the page kind of can display a bit differently depending on the ID that they pass through. It's nothing like user specific. It's just literally for a per travel agent. And this is just showing the bit of code that we use to grab this particular cookie from. So it's quite simple. We also have contracts with our agents so that the overriding factor of who kind of gets the booking in terms of distribution. So we start off checking the URL. If this ID isn't in the URL, then we'll look at the cookie, and if it's not in there, then we'll try and assign something that's a default. ECLs for debug and data. We use ECLs probably in a slightly unusual way maybe, in terms that we allow specific sections of our data center or our website testing features, and only requests coming from those IP addresses are able to see lots of kind of extra header information, and we use those headers from the site monitoring point of view to check Varnish and how things are working there, kind of store that information and take it through to later stages. Per user agent caching, found in some cases that caching on the user agent was causing a few problems. So what we did is we had a specific bug, for example, across IE 6, 7, and 8. So the best way to keep a decent cache hit ratio, as well as including that user agent within the hash of Varnish for its caching, was to just amalgamate those three user agents or different browsers into one. It made no difference in terms of what the customer would see, and it would fix the bug, but we would have a higher cache hit ratio, and the code at the application level would still work just the same and still serve the correct content. We do some kind of really simple mod rewrite stuff, but we do it in Varnish instead of it in the Apache level. You can see at the beginning it's just some kind of simple bit of code there, just showing roughly what's going on with some applications being allowed to hit and some not being allowed to hit the cache. And then we go into the user agent. So we redirect based on mobile site. So we've got our own mobile site, and we redirect based on the user agent. So passing an iPhone or an Android. If it is an iPhone or Android, it would go into this if statement, and they'll kind of work their way through, just really deciding whether it should be allowed to visit the mobile site or not. It kind of goes down to the point of it's kind of a little bit complicated in terms of the way the mobile site functions. So when we get a request from a user, it has, like in the URL, a location and then a load of arguments. And we just need to make sure that we formed the URL correctly when doing the redirect for a mobile user. So it would be something like PURL equals, and then that's meant to be location, if location existed and that kind of thing. So we use all of these regular expressions and a couple of if statements in order to make sure that we sent a valid URL back to the user for the redirect, but also so that the mobile site worked correctly if the user somehow came into the www website. And of course, it's calling the error 600 VCL, which is just saying, okay, well, we've already built the HTTP location path in this section. It's just literally adding it together with the m.holidayextras domain and saying, okay, let's redirect this. Simple stuff. We just use grace mode. We find it pretty handy, so it's literally just a little mention on that, really. One of the problems we did come across when using Varnish, though, within or up against the cloud, is elastic load balancers. So AWS have elastic load balancers, which switch IP addresses every so often. The problem we have with Varnish in that respect is that Varnish, when once started, keeps the same IP address, and it doesn't ever change them unless you kind of restart Varnish or change the VCL. So the kind of idea we took on to combat this problem, so we could still use Varnish, was to add in this kind of templating filter type addition. So just kind of look at the hash.host equals, and then there'll be domain name, closing hash. We have a script that would look at the Varnish config for the back end. It will check on the domain name and then replace the host header or the host IP address underneath that. So that's just a snippet of the script. It's just a simple bash script, really. It kind of takes the current Varnish config file, strips out the host equals IP address, and then looks through all of the different host names or domains throughout the config file. And then for every section where there's a host name, it outputs the IP address. The important part there being that when you're doing a DNS request based on the host that's in the backend configuration, you need to make sure that the output for that DNS request, like for the dig, for example, outputs all of the variant of or various IP addresses available to your backends, which means you don't have to make several DNS requests to try and find all of the IP addresses. You just do one and it passes back all 3 IP addresses, for example, and then you just put those throughout your code.
Sorry, can I just ask, so you're going from your Varnish things back into ELB again? You're double passing through the...
No. Varnish is fronting elastic load balancers, and then the elastic load balancers just pass on to the actual web application.
Right. So you're sort of not using the Varnish ability to use multiple backends?
We do have multiple backends, but because the elastic load balancer, or the elastic load balancer gives out multiple IP addresses, but those IP addresses can change. So the problem is we need to make sure that Varnish always keeps up with the IP addresses, otherwise the backend's going to die, and so on.
So I just no, I use ELB as big. I'm just confused because you're sitting inside AWS.
Yep.
Inside their 1918 space.
Varnish is outside of that though.
Oh right, sorry, I thought you were...
Oh no, yeah. So Varnish is out. Varnish is in the UK in our data centers, and then our web infrastructure and most of the other stuff is all in AWS.
Thank you.
Right.
But can't you skip ELB and go straight to the EC2 instances I'm guessing you're using?
You can do, yes, but it's kind of the same sort of problem. So you've got to rely on the fact that when you're working in the cloud, servers can disappear immediately. IPs are not static, although you do have that kind of option to make them static. And then you're still going to be changing the config file when the server dies and then another one comes up and all that kind of stuff.
I mean, then you can use this approach that you made to have sort of dynamic host names,
Yeah.
but straight to the instances instead of to ELB and save yourself a bundle of money.
Yeah, I understand. The other cool feature with using elastic load balancers is that they automatically register the instance with that load balancer, so we don't have to do any work because it's automatically done for you by Amazon in that situation. Zabbix does alert on failure if we ever fail to compile, so we check the compilation after we've rewritten the configuration file. As you can see there, it's just checking that there's no stack trace from the new configuration file that we just created, and if all of the tests pass that we have after that, then we'll put the new configuration file in place. But this misconfiguration problem has not occurred yet, so touch wood, that stays the same, and everything carries on working. We push our Varnish NCSA logs to S3, and we've kind of customized the format slightly using kind of the additions of things like time to first byte that you get from the Varnish extensions. We do a bit of offline report generation based on those time to first byte statistics, and it's just a graph showing some of the stuff that we tend to report on. And we do this at the Apache level as well. But if there was something we would like to have seen further, it would have been more timing information in the extended variable set. However, after hearing about Vstats D today, it kind of looks like that stuff is already there. So we'll be looking into that quite soon, I can assure you. But thank you for listening. Thanks again to Varnish guys and the BBC for sponsoring the event today, and any questions?
I think we should just mention that stripping off the age header in deliver is not a good idea if you're using max age in cache control. We just noticed this seeing your slides. So,
yeah, that we allow Varnish to configure its own max age rather than the backend setting it.
So you're dynamically setting it.
Yeah, in Varnish. Yeah, in another
deliver.
section of Varnish.
Yeah. Okay.
Yeah.
All done?
Yeah. All right. Cheers.